To start off, the introduction is we have our purpose, which is using clear Scotch tape to observe electron transfers. Our principles, Coulomb's law, Newton's second law, Newton's third law, dimensional analysis, as well as the results. The charged tapes repelled each other, the tapes were positively charged, and the charge on the tape was around 1.5 times 10 to the negative 8 coulombs. The magnitude of excess charge, around 9.6 times 10 to the 10 electrons. The assumptions we make are there's no air resistance. We treat the tape as a point charge, where all the charge is concentrated at the center, and we assume an even charge distribution throughout the length of each U-tape that are equal in magnitude. So the model that we assume here is the initial conditions, where the tape is 0.2 meters, 20 centimeters. It weighs about 0.002 kilograms, and the distance between the A and B tapes was measured to be 0.031 meters. And so we can see here on the right side that we calculated the magnitude of gravitational force, and that rounded out to about 1.96 times 10 to the negative 3. And you can see the calculations here. We set the F sub G equal to F of E, then we isolated for Q, which we got Q equal to mg times 4 pi epsilon naught times r squared square root, and that ends up working Q out to be 1.5408 times 10 to the negative 8, as we showed on the earlier slide. Now to walk through some of the calculations, the electrons on tape B is we took the amount of charge over the charge of an electron, which worked out to be 9.63 times 10 to the 10 electrons, which is the excess charge of electrons. And then we did the ratio, the number of atoms on the tape to the number of atoms on the electron, and worked out to be 2.41 times 10 to the negative 7. And so we also repeated our calculations there for the charge on the right side. And now for our observations, when we saw a tape 1 with a hand, it had an attractive force. Tape 1 and tape 2 had a repulsive force. Tape 1 in a random book had an attractive force. And then tape 1 in a negatively charged pen had a strong attraction. This led us to conclude that the tape strips, in fact, have a positive charge. So as we can see here, we have some of our glowscript code in our model on the right side. As you can see, we input our initial conditions in the beginning, as you can see here with the laser pointer. Then we set the two forces equal to each other. And then as you can see, we have our vector input and calculations, and then our free body diagram model. And as you can see, our calculations worked out here, just about to what our calculations worked out by hand. So now we want to think if the electrons had a positive charge and protons had a negative charge. So really this wouldn't change any of the observations we made, essentially because the model of the system is still the same, it's just flipped. So now the protons will act as electrons and the electrons will act as protons. And so it's important to handle the charged tapes as little as possible because we don't want any of that charge to be released, because essentially what happens when it comes into contact with our hand or objects is it acts as a grounding force or transfers the charge away from the tape. All right, that's all. Thank you very much for watching. This has been Patrick Young for Physics 2212.